Day 5. This was a fun one. I liked it a lot. So let's look at our example input. We start out with 4 seeds, each represented by a single integer. Each of these integers undergoes a series of mappings, transformations, always to another integer. And at the end of that, we end up with location numbers. These location numbers, we need to compare them and take the lowest one of them and return it. So we're looking for the lowest location number. Let's see how these mappings actually work. So we have 3 numbers in each line. We could call each of these lines a conversion. So here, for example, we have a destination of 52, a source or start of 50, and a range of 48. This means that we map 50 to 52, 51 to 53, 52 to 54, and so on, for 48 numbers, for a range of 48. So we do this up until the number 97, which will map to 99. Then when we hit 98, we do something different. We take this 98 and map it to 50. So it's important to note that these conversions are mutually exclusive. They never overlap. And another thing to note is that if a number goes through all these conversions and never finds an interval where it fits in, then it remains unchanged. For example, the number 79 down here, it's not in this range, it's also not in this range, it's also not in this range, so it would just remain the same. Okay, let's jump to the code. So the first thing we want to do with the puzzle input is to separate the different maps from one another. We're going to call these segments. So whenever there's 2 new line characters right after one another, we know it's a new segment. The seeds will get their own segment, the seed to soil map will have its own segment, soil to fertilizer map, and so on. The first segment is the seeds, and we'll retrieve all the numbers from it. For this we'll use the regular expression module. And we use the find all function together with /d plus. D is digit, plus is multiple, so multiple digits make up a number. We find all the numbers in the seeds, and we map these numbers to integers because right now they're still strings. And now we'll go through 3 nested for loops. First one, we iterate the numbers, the seeds I mean. Second one, we iterate the segments or the different mappings, starting at segment 1. And the third is we're going to go through all the conversions within each map. And here also we're going to look for 3 consecutive numbers, so /d plus, /d plus, /d plus, each of which are encapsulated in parentheses because they're that way regular expression returns them as groups, so we actually get a tuple of 3 numbers. And right away, as we unpack these tuples of 3 numbers, we can turn each of them into an integer using the map function. Now that they're integers, we can check if the number we have is in the range defined by start to start plus delta, the middle number to middle number plus the right number. If it is, then we add the difference between the destination and the start, so destination minus start. And if this is the case, if we did it, we have to break. This is really important because if we don't, then there's the danger of going through multiple conversions inside of the same segment. The break statement ensures that we break out of the for loop. The for loop ends, and we move on to the next element of the for loop above. So the break statement doesn't end all the for loops, just the most immediate one. After having completed the inner 2 for loops, our seed number should have turned into a location number. Now we add this location number to a list that we initialized at the beginning, and then once all the seed numbers are appended to that list, we can print them. We see 82, 43, 86, 35, and we take the lowest one of these, which is 35. Or actually, let's just check real quick if these are the right numbers. So we have 82, 43, 86, and 35. Perfect. We got it right. Now we take the minimum of these, which is 35, and that's our puzzle answer. And that is it for part 1. Part 2 is basically the same exact problem as before, still looking for the lowest location number, but now we're supposed to reinterpret what the puzzle input means. These are no longer supposed to be 4 individual numbers, but rather 2 intervals. This interval starts at 79 and has a range of 14, so it goes up to 92. And likewise, this one has this as a start and this as a range. So now we could basically try the same thing as before. We could not change anything, just take a brute force approach of going, so we have a seed of 79, a seed of 80, a seed of 81, and just pass all these numbers to the conversion pipeline and see what comes out. But this is actually very computationally expensive, and it might work on the example input. It's not going to work on the actual puzzle input, so we have to find another way. I love these problems because it always has a twist in it. So let's imagine if we didn't pass the individual numbers to this conversion pipeline, but instead the whole tuple. We pass in a lower bound and an upper bound, so 79 and 92. What would happen then? So there are basically 3 options. Let's say a given conversion interval lies outside of this interval, so there's no overlap at all. In that case, it wouldn't be any problem. It would just not be touched by it. Second case would be this interval is inside of the conversion interval, so both this one and the 92 are inside of the conversion interval. In this case, both get converted, also not a problem. The whole interval just switches values, gets converted. The only problem arises when one of these numbers are inside the interval and the other isn't, because then we have sort of a split. So this interval would sort of have to be partially converted and partially not. So how do we deal with this? I would say we create a sort of to-do list data structure that we push unfinished jobs into. So we start off with some interval, and whenever there's an imperfect overlap, we stick with the current interval that gets converted, and the part that doesn't get converted, we push into a do later list, basically, like a list of things that we, a list of intervals that we will deal with later. All right, let's jump right in. I think a lot of this will make more sense as we go along. So first, we're going to extract all the seed tuples from the seeds list, and we're going to define x1 as the lower bound of the interval and x2 as the upper bound of the interval, where x1 is inclusive, x2 is not inclusive. And then we're going to add these 2 variables to a list called intervals. This will be our to-do list. And we're going to include another number, which is 1, because we're at the first segment. We start at the first segment, so this will be the current segment index. Then we're going to open up a while loop. While loops are actually perfect for this type of data structure, this to-do list, because we're saying while we have stuff to do the next thing. If we don't have stuff to do anymore, then we'll stop. And that's what we're doing here. We'll pop one element from the to-do list, see if it works, and it does. Now we have a lower bound, an upper bound, and a segment index. We'll use the segment index to retrieve the conversions from the current segment and then iterate through these conversions. It's best to use a regular expression again to make it easier for us. We'll retrieve the destination number, the start number, and the delta, the range. Again, we'll use map int to turn them to integers straight away, make it easy for us. And we'll immediately calculate the difference between destination and start, so we know what to add to x1 and xy if we convert it. Now the first thing that we check for is there any overlap? Because if there's no overlap at all, we can just move on to the next conversion and not be bothered with this one. So we check, is our x1, is it higher than the end of the interval? Then there would be no overlap. Or is the x2, the top of our interval, lower than the start of the conversion interval? In that case, there would be no overlap at all, so we move on to the next conversion. After that, we have to assume that there is some kind of overlap, but we don't know if it's perfect or not, so we'll check, is x1 lower than the start? If so, we'll have to shave that part off. So we'll put it in the to-do list for later with the same segment index, not changed at all. and we'll redefine x1 as the start of the interval to create a perfect overlap. We do the same thing with the upper bound. If x2 is too high for this interval, then we have to shave off that part of of the interval that's too much, and to redefine x2 as the end of the interval. Now there is perfect overlap, and we'll add this conversion to the interval list with a segment index of +1, meaning it moved on to the next stage. After that we have to break because we're done with this segment. We don't want any more conversions inside of this segment. And then we have to take care of another case, which is what if the interval runs through all the conversions but never finds any overlap with any of them? In that case, it still needs to move on to the next segment. So we create an else clause. If the for loop runs through and never hits the break, it enters the else clause. Finally, we have to think about how do we end this? How do we know that an interval is done? Well, it's done if the segment index gets too high, because we know that we've run through all the segments. So in that case, we can skip it, we can move on to the next interval, but we also have to record the result. We'll start in a list called location numbers and append only x1 because that's the lower of the two. And at the end, we're going to take the minimum of that list and return it, and it's 46, which is correct. That's it for part 2. Thanks. If you're also a big fan of Advent of Code and it's helping you to learn to program as it helped me, you might also enjoy visiting my website where I keep all the solutions I've got so far, presented in an interactive and hopefully appealing way, as well as other fun stuff. See you there.